Hello and welcome. My name is Charles Johnson, lead trainer and technical engineer at Lynxspring. And today we are going to finish this three-part video series or a three-part video series of hierarchies with actually building the hierarchies. So we're going to go over a few query level definitions, a few group level definitions, what it's like to use relation level definitions in some of those hierarchies, list level and the name group definitions, as well as going through a few query context examples, and hopefully break them down to where they actually can be understood. Because query context can actually be really strong if you're good with them, but it takes a while to really understand what's going on. So remember that if I go to my config space and I go to my services, I build everything. Every hierarchy is going to be built in the hierarchy service. And then we view them in the hierarchy space right here below file space and above the history space. So you're going to see all the hierarchies that we built here. Now, when we build them and you don't see them immediately, what you're going to have to do is you're going to have to right click on the hierarchy space and select refresh tree node. That's actually the best way to do it. Even though that there's a timeout in 45 seconds, it doesn't refresh it. So you'll have to refresh it here, at least to see it in Workbench. However, through the web, you'll see it refresh. So let's go ahead and start off with group level definitions. Now, remember, group level definitions search by a string tag only. So based upon what's in that string, you can actually create several groupings. So if you remember from my last video where I was tagging things, and by the way, I still added some additional tags later on after that video, which I will explain what I did in each of those scenarios. But in my power meter section, I am monitoring different meters in different locations. So if I go to Views and Tag Manager, we can see this power meter has got quite a few things here. We have equipment type, we have vendor, we have the GeoCity and the GeoState. So the GeoCity and the GeoState here give me a location that we can do. So as long as I group by state first and then city second, or if there was a county, state, county, city, that kind of thing. Like, you just have to build your group level definition in order. So remember, all hierarchies have a specific order. With group level definitions, you want the largest one first, then the smallest, the one that pinpoints it down even further second, and then, keep going, and then we will use a query level definition. Remember, all hierarchies need a query level definition regardless. It's actually the only way that they actually work. So let's build our first one using a group level definition. So again, I want to go ahead and I want to group my power meters based upon state and location. So I'm going to go to my services container and I'm going to double click my hierarchy service. Now this brings up by default the AX property sheet. And what I recommend for you to do is to actually always work in the AX property sheet. And when you bring a hierarchy in, you should always work within that hierarchy. And the reason being is that working in the smallest space possible will actually diminish the least amount of errors that you can find. I get a lot of people that will say, Charles, I'm having this drop-down menu, this drop-down error, and I'm like, well, you're not in the hierarchy, and they're like, they are. I'm like, no, you're not. So here's what I mean. So I'm going to drag my first hierarchy over, and I'm going to drag it to more the bottom of this screen here. So that way we can see that the hierarchy service at the top was actually highlighted. So it highlights it when I drag it here, and it highlights it here. So I know that I'm actually working in the hierarchy service. And now I'm going to name this one Power Meters. And now I'm going to go ahead and click on my power meter hierarchy, and now I'm in the hierarchy itself. So now, because I want to group this by state and name, or state and city, I'm going to go ahead and drag over a group level definition, and I'm just going to name this state. And I'm going to expand the group level definition to expose the query here, but it's actually really, again, based upon a string. So I'm going to do the haystack. So HS stands for the namespace for haystack. So anytime you see a dictionary, it's always going to be namespace in lowercase, colon, and then the tag name. So HS stands for haystack. So haystack colon geo state. So I've got my first one there. So now it's going to group everything by state first. And now I'm going to drag a second one over. And I'm going to name this city. And as we named it by geostate, this one we're going to go by geocity. And the last thing that we need. So if you notice that the hierarchy can start to be built if I refresh the tree node. And, however, I don't have anything here. Why? Again, because there's no query running this hierarchy. So now I need to drag over a query level definition. And I can do multiple things here. So I'm going to just name this get meters. Now, however you would like to get meters, it's really going to be up to you. Again, there are multiple ways to skin the cat here. The first one is going to be especially, you could just put in true. And if you put in true, it's actually just going to run against the entire database and then only sort with these specific tags here. So I could do true. Or I could do n:\device. So I could look for anything that is that has this specific tag here only, and then sort here. But I also know that they're only Modbus meters, so I could also do the n:\type space equals space, and then in quotations Modbus Modbus TCP device. The only reason why this one wouldn't really work out too well is if we added some meters that were either LAN or BACnet that we added these tags to. So this here is probably not the best one unless you know every device you're going to do is a Modbus TCP device. So here I'm just going to select true. And now if I refresh my tree node in my nav tree here, we can now see that I have Maryland and South Carolina. And I have 3 cities, Baltimore, Parkville, and Pasadena. And you can see that I have my power meters in each of these. So that's a good one to start. Now, the next group level definition that I'm going to do, and again, I'm going to double click my hierarchy service, is I'm going to go ahead and with those devices, you saw I had equip type, but I also had vendor. So let's say someone wants to see what vendor has which device. So I'm going to drag another hierarchy over to my hierarchy service, and I'm going to just name this devices by vendor. And so here, I'm going to go ahead and single click to work in my specific hierarchy. And I'm going to drag over a group level definition here. And I'm going to name this vendor. And I am going to group by my tag CJ:vendor. And of course, since every hierarchy needs a query level definition, we're going to bring in a query level definition here. And we're going to make sure that all devices we're going to look at, not the entire system, but anything that has anything that Niagara considers a device. So I'm just going to name this devices. And here I'm going to go ahead and go n:device. And so now if I refresh my tree node, I now see that I have my devices sorted by vendor. So those are the only two group level definitions that I'm going to do right now, but you can see again that a group level definition only searches for a string tag. Now I'm going to do just two straight query level definitions. One of them could be useful, the other one maybe not so useful, and I'll explain why. So I'm going to drag another hierarchy over into my hierarchy service, and of course I'm going to double click in there first. I'm going to name this set points. So I just want to return a list of all my set points. So I'm going to go ahead and drag. I'm going to go ahead and first click here to work in the AX property sheet of the hierarchy. Drag over a query level definition and name it get set points. And here I'm going to look for anything that has the haystack SP tag attached to it. So HS:SP. And remember, we tagged all of our set points using a tag rule, so it is an implied tag and not a direct tag. And with that, I'm going to go ahead and refresh my hierarchy tree node, or my hierarchy space. And now we can see all of my set points. However, this one's not very useful, but it just shows what a query level definition does. It just returns a tag. That's all it does. So there's no way to find what device this belongs to, right? Hot water temp set point. I know that that's a boiler, but I don't know which boiler. Chill water temp effective set point, chill water temp set point. Well, I know that belongs to chiller, but I don't know which one. So we're going to expand on this one a little bit later on when we get into query context. Now, another hierarchy, one that is more useful, is if I drag this one over, I'm going to name this one get schedules, or I'll just name it schedules. And I'm going to expand on that one too, using a different kind of hierarchy. So I'm going to go ahead and click on my hierarchy schedules, or my schedules hierarchy. I'm going to drag in a query level definition. And I'm going to say get schedules. And here I'm going to do HS::awk. So I had tagged my my schedules with HS::awk afterwards. So if I went ahead and refresh my tree node, again, we now see all the schedules. So this one's actually definitely useful because you can see all the schedules. So what we're going to do though is we're actually going to break these two down to something that actually could be more detailed than what they are currently. Another common query level definition that I really like using is something called n::has_px_view. So I currently don't have any graphics attached in this particular demo that I'm doing, but if I did, it would anything that has a px view. So I'm just going to type it up in here: n::has_px_view. And right now it's not going to return any results. So this N has PX view. Anytime a PX view gets attached to a component, it gets tagged with this. It gets tagged with this. It gets this tag here. So if you just want to search, like do an entire graphics hierarchy without any additional grouping or anything like that, you can use this here, and it's going to return anything that has a PX view attached to it. So you'll have to change the query to probably remove a couple things, especially if you have like things like headers that you created a folder for, rather than just a straight PX page. So just be mindful of that you may have to modify this search a little bit, or modify this query. So that is the query level definition. And now let's go with relation level definitions. Now I could add relation level definitions to either my power meter or my vendor, but I'm going to do a query level and a relation level definition in 2 more queries here. So I'm going to go back to my hierarchy service, and I'm going to drag in another hierarchy, and I'm going to name this one devices endpoints. So I'm going to go ahead and work in this one. And remember, I also do have points in my Niagara network as well, or devices in my Niagara network. Maybe I don't want those devices, but we're going to think about that for a moment. But the first thing I need now is a query level definition, and I'm going to name this devices. And if I just do here n:device, it's going to return anything that has a device. To show you, if I right click on my hierarchy space and refresh tree node, now we can see all my devices that I have here, including my my Niagara stations, as well as my local LAN device. So maybe I want my East Campus, North Campus, South and West Campus here, but I don't want this local LAN device. Well, I'm going to go ahead now and modify this query and say n:name does not equal, all in quotations, local LAN device. Now, why is it this and not this? Local space, LAN space, device space. Well, that's actually the display name of the local LAN device. But if I actually look for the name itself, well, that is what it's actually going to give me. And now if I go ahead and hit save here, and of course I refresh my tree node, we can now see that local LAN device is actually no longer here. Well, let's say I don't want my Niagara stations in here either. So if I want to do that now, this is where it gets a little tricky, but it still works. I need to put this in parentheses here to make sure that it resolves this first and then the n:name second. So I'm going to say n:device and n:type space does not equal, so exclamation point equal sign, Niagara driver colon Niagara station, end quote, parentheses, close parentheses. And now if I hit enter and I refresh my tree node, we now see that I have only my LAN and BACnet devices here. So that's great, but I said device's endpoints. It doesn't bring the points here. Well, I need to relate the points to the devices. So in order to do that, I'm going to go ahead now and drag in a relation level definition. And I'm going to name this points. And now, in my outbound relation, I'm going to do n:child point. And now, if I refresh my tree node, and I go here, now we can see that I've got my points underneath. I like to see that. That is a more functional hierarchy that we have. So the next query level definition that I'm going to do, it actually requires two relation level definitions. So again, I'm going to go back to my hierarchy service. And I'm going to drag in another hierarchy. And now this one I'm going to do AHU and VAVs. So what I've done here is, remember, I related a group of VAVs to a specific air handler. So now I want to go ahead and put those VAVs under the air handler and show the VAV points itself. So single click on your hierarchy here. I'm going to drag in a query level definition. And I'm going to say AHUs. So the first thing that I need to do is find those specific AHUs. And we only did two of them. So the first one is going to be HS:AHU and HS:VAV. So I'm looking for air handlers that have both of these tags. And if I refresh my tree node, I can now see that I'm on the right path, that at least I have the two air handlers that I need. Well, now I need to relate the VAVs to the air handler. And we do this by finding a relation between the two. So I'm going to drag a relation level definition over. And I'm going to say VAVs. And now I'm going to have an outbound relation of my AHU rel that I did in my custom tag dictionary. So now, if I refresh my tree node, I now have my air handlers and my VAVs. But I don't have the points underneath my VAV. So now, if I want to do this, I'm going to do a relation level definition. And I'm going to go ahead and name this VAV points. And now I'm going to go ahead and look for n:child point. And now if I refresh my tree node, I can now see the points underneath my VAVs here. So that one I kind of like showing because it does show a different way. Now, we could create something more complex with that with query context, but we're going to do two different examples with that. So we've gone through just a group level definition, and remember, with these group level definitions here that I've done, let me hit the backspace here. Go to hierarchy service. With the group level definitions that I've done, I could also put the relation of n:child point underneath each of these after the query itself. Why? I could then, if I wanted to show all the points for there. So in my power meters, right? If I drag a relation level definition over, and I'm going to say get meter points, and now I do n:child point. And now I refresh my tree node. Now I can show my points underneath my group level definition. So you can drag relation level definitions anywhere as a specific relation. So you just have to be mindful of where you put it. And really, it's going to be the bottommost one. So again, like your list level and name group definitions are going to be first. Then you're going to need a query to return that list or group. And then you can actually relate the points to those specific groups. So now, back in the hierarchy service, let's go ahead and do 2 list level and name group definitions. Well, the first one that I want to do is a schedule breakdown. So I showed you all the schedules here in this one. And if I go to the hierarchy space, you can see all the schedules that I have. Well, let's say I want to break them down actually by type. So now I'm going to go ahead and drag a hierarchy over here, and I'm going to name this one all schedules by type. Let me rename that one by type. And I'm going to go ahead and click on it again to bring me back in the hierarchy space here. And now I'm going to do a list level definition here, and I'm going to name this schedules. And remember, this just returns. This is just going to help me get a list together. And the name group definition is going to help get me my Boolean filter for effectively my folders. Remember that a list level and name group definition actually are in pairs. So that's actually the real big thing there. So they're a pair. So they're paired to create a structure similar to that of a group level definition. However, they allow for the use of other types of tags beyond a string. So like a marker, for example. So the list level works with the name group definitions, and in the hierarchy, folders are created with the name group definition. And the name group definition is used to locate those components that meet the requirements of that NEPL. So now in this hierarchy, I'm going to go ahead and select schedules to work in the list itself. And I'm going to drag a name group definition over. And I'm going to name this name group definition here. I'm going to name this one Boolean schedules. And now in this query here, I'm going to use the n:type tag to determine what type of schedule I want. So schedule, Boolean schedules, or a Boolean schedule. And now if I duplicate this a few times, I'm going to name this one numeric. Enum schedules. String schedules. And name this one calendar schedules. So now I'm going to go through and change each of these from Boolean to numeric. Boolean to enum. Boolean to string. And then Boolean to calendar. So now I have my Boolean filters set up using the n:type tag for each of my schedules. Now I need a query to start generating this. So I'm going to go back to these schedules by type hierarchy. And remember, in the locator bar, it tells me exactly where I am. So I just need to click on the schedules by type hierarchy to bring me back to the hierarchy itself. And now I'm going to go and bring in a query level definition and just name it retrieve. And I'm just going to say true. Instead of trying to figure out what type of schedule I want, I'm just going to go ahead and run this query against the entire database, and then it'll give me anything. It'll put whatever is in those filters in the specific folder. So if I refresh this tree node, now schedules by type, Now I can see my Boolean schedules that I have, my numeric schedules, my enum, my string, and my counter schedules. And now the last name group definition I'm going to show you. So remember I have devices by vendor here? Well, what if I wanted to separate them by their type? So whether they were a BACnet, a LAN, or a Modbus device. Well, if I go back to my hierarchy service, I'm going to use the same principles as I did right here. As a matter of fact, I'm just going to go ahead and duplicate this. And I'm going to name it devices by type. So instead of dragging all these back over here, I can now just rename them. Devices. And if I click here, I'll name this one BACnet device. LAN devices. Or LAN works devices actually is probably better. Modbus TCP devices. We can delete this one. And you know what? I actually will show you Niagara devices or Niagara stations. So now, this type here is going to be BACnet, BACnet device. So the module name will be lowercase, at least for the first name of it. And then it's going to be capital letters for each word for the type that I need here. So I'm just going to go ahead and paste this on through to each of them. And now instead of BACnet, it's going to be LANWorks. But now we're going to look for a dynamic device. And then Modbus TCP. Modbus TCP device. And now this one is going to be Niagara driver and Niagara station. And I hit save. So my query level is still true. So now if I go ahead and refresh my tree node, we now see that I've got my devices here. Now since I've done that here, maybe I want to go back to my campuses and add a Tritium equipment type to match my devices by vendor. I may do that. However, now with this devices by type here, now what if I add a relation level definition to the bottom and say get points? And I say n:child point. And now if I refresh my tree node, now I have points underneath here. So again, you can put a relation level definition in most of your hierarchies to relate something to another. So with this now, let's talk about, again, query context. So with query context, query context, effectively, you can create a temporary storage for a key value, such as like building ID, equipment ID, AHU ID, whatever it is, based upon the HS:ID tag. That is a unique number for each component that is added to the system. So every time we add something to the system, it's going to get this HS:ID tag. So we can go ahead and return queries to generate a temporary storage for this specific value to be used later on in the hierarchy itself. So let's go ahead and get started here and see if it makes a little more sense once I start doing one. So I'm going to start with the set points here. And I'm going to name this set points breakdown. So what I'm going to do is I'm going to add my set points here. Or I'm going to create a hierarchy that's going to break down the set points by device. So I'm going to use a list level and a name group definition to do this. So the first one is going to be, let's see, the list level. And I'm going to say devices. And now in the name group definition, I'm going to go ahead now and go ahead and name this one AHUs. And the query here is going to be n:\name like AHU dot star and n:\device. So I'm going to go ahead and use this for a lot of them. I'm going to say I have AHUs, I have VAVs, and of course rename this VAV. And now I do have one for RTUs. What other things do I have here? I have chillers. And let's say another name group definition. Yeah, we'll say chillers. And we will go ahead then and go n:\name like chiller. And we'll do one for boilers as well. Okay. So now that I have the devices that I want, and I'm not doing the power meters because, well, I don't have anything in the power meters. And guess what? If I need to reorder this, I can by right-clicking on the list and go to reorder. So if I want to do the RTUs, AHUs and RTUs, and VAVs and chillers and boilers, I can do that first. I could also sort by name if I want to. And now that that part's done, let's go back to the set point breakdown. And now I'm going to go ahead and add two queries here. So the first one is going to be retrieve. Okay. And so now I'm going to add something in the query context here. And to do that, I'm going to add a key here, and I'm going to say unit, and I'm going to say HS:ID. So what this is going to do is that now when I return my query, it's going to put everything it's going to give everything in it's going to use the ID and give it a unit for now. And then I'm going to use a second query to go ahead and return everything whose parent device has a set point tag and the unit ID itself. So I'm just going to name this one true. So now this is creating a temporary storage for this specific value here. And now I'm going to add a second query level definition here. And I'm going to name this one set points. And now what I'm going to do here is I'm not going to put anything in the query context, but I'm just going to say I'm looking for anything that has the set point tag and its parent device is traverse, and I'm doing what I now is a traverse. So now what I'm going to do is I'm going to look for anything with the parent devices that have the set point here, and it's now going to give me the device breakdown. So now it's going to look for anything with that unit there. So we have to do, I forget what this is, some kind of brackets, but I forget which ones they're called. But you need those and not the regular brackets. And now if I hit save and I refresh my tree node, I now should get all my air handlers with my set points here. Let's go to the VAVs to show you. Chillers. So that's a pretty good one there, a set point breakdown. Now, the last one I'm going to show you, and this one here takes a little bit of thought to do. Remember, another thing I didn't show you, and it was really an afterthought. And I may go back and edit the video to show this, but I'm not too sure. However, what I did is I went ahead and with the tags in my tag dictionary under my custom, I used a couple more relations. I used the building rel, floor rel, and equip rel. And what I did is I right-clicked on my North Campus and I went to relation mark. And then from there, I then went to each of my floors and went relate to. So for example, here, relation mark. I went to each of my floors and I went relate to North Campus. And I went to building rel. So I related the buildings to, or the floor to the building. And then in the same process, I related this stuff to the floor, and then this stuff to this exhaust fan control folder here. So what I'm going to show now is a breakdown of building, floor, and some points underneath my equipment there. So let's go ahead now and break that one down. So that one takes a little more, this one's a little more complicated, but again, this is going to show you the power of query context here. So here I'm actually not going to have any relation level definitions at all, and you can see that I didn't have any relation level definitions in my other one using query context, and I was still able to break everything down. So I'm going to drag another hierarchy over, and I'm going to name this one site plan. And in this site plan, go ahead and work in here. And I'm going to add a query level definition first here to say buildings. And I'm going to add a query context here. So this query context I'm going to add, and I'm going to say the first one is building ID. And I'm going to say HS:ID as my value. And in my query here, I'm going to look for my building tag. So now it is searching for the buildings and taking the ID of that and putting it into this building ID value that I have. And now, if I were to refresh my tree node, we can see now I have my buildings. And now if I drag in my query level definition here, and I'm going to name this one floors. And in the query context here, I'm going to go ahead and add another one that's say floor ID, HS:ID. And now what I'm going to do is I'm going to look for anything that is tagged with a floor, and I'm going to search for my building relation and traverse it with my building ID equals building ID. So now if I refresh my tree node, I now see my floors. I'm going to add another one here now, and I'm going to name this one equipment. And now in this query context, you guessed it, it's going to be equip ID. And this one here is going to be HS:ID. So you can see what it's doing here is that it's taking each of these, and once I query them, it'll go ahead and now add, it adds it now to that relation. So as long as it puts everything underneath, everything where I need, the query context is going to work. And now this one here is going to be HS:equip. And my floor relation, and I'm going to traverse that. Traverse with HS:ID equals floor ID. So now if I were to refresh the tree node, we now see that I have this, and now I'm going to put points underneath there. So one more here, and I'm going to name this points. And this one, I don't need to add a query context here. I just need n:point and my equipment reference, or my equipment relation, equip rel is HS:ID, and now I'm going to add the equipment ID to this. And now if I refresh my tree node, let's see here. Did I do equip ID properly? Oh, nope. See here, I did equid ID. So now if I do equip ID, to do that, you have to delete this. Actually, you know what? I will go ahead and just change this. It's easier to do that. And now if I refresh my tree node, let's see here. What did I do wrong? Rel, equid ID equals, let's go ahead and add the equal sign here. There we go. I don't mind necessarily making those mistakes. I know some people who create the content don't like their mistakes being shown. I definitely don't mind, and the reason why is because number one, I'm not perfect, but two, it also can help if you're doing this. You're like, hey, what happened here? So now I can just go back to the steps of what everything is needed, And now I can actually see everything that I have. I could have added an additional one to show the space temps here. I chose not to do that for a reason. I just kind of wanted to get you the idea of how you can break down and group this here. So I think that's really one of the most complex ones that I do, or that I can do for a query context. You can look up more on query context in the doc hierarchies. There's a lot more information on it. But hopefully this video here has been very useful to you, and I hope that you'll use more hierarchies in the future. So until now, have a